3 electrical question number 41. For a 400 kilometer long transmission line, the series impedance is J.5 ohm per kilometer and the shunt admittance is J5 micromho per kilometer. The magnitude of series impedance in ohm of the equivalent pi circuit of the transmission line is being asked. For NPTEL reference, you can refer to lecture number 3, Propagation Constant, Characteristic Impedance and Reflection Coefficient of the NPTEL course Transmission Lines and EM Waves by Professor R.K. Shivakaonkar, Department of Electrical Engineering, IIT Bombay. For useful data, you need to know characteristic impedance of a transmission line with net impedance Z and admittance Y is given by ZC equal to root over Z by Y, and the propagation constant gamma is given by root over Y into Z. Now the magnitude of series impedance is given by ZC sin hyperbolic gamma L, where L is the length of the line in kilometer and gamma is the propagation constant. Now the sin hyperbolic property for a complex number IZ, where Z is the magnitude of the complex number and I is the imaginary iota, so it is equal to iota times sin hyperbolic that complex number Z. That is the magnitude of the complex number Z, because I sin we are taking out. That is the property of sin hyperbolic. For Z to be a purely imaginary number, that is the magnitude of Z and I is the iota, it can come outside and then we can write sin hyperbolic Z. The given value of Z is J.5 ohm per kilometer and Y equal to J5 micromho per kilometer. L equal to 400 kilometer implies that it is a long transmission line. The value of ZC equal to root over Z by Y equal to whole root over J.5 and Y value is J5 into 10 to the power minus 6 because micro. So this is coming out to be 316.22 ohm. The value of gamma, that is propagation constant, is root Z into Y, which is equal to whole root over J.5 into J5 into 10 to the power minus 6. Note that all Y and Z are per kilometer quantities. Now this is equal to J1.58 into 10 to the power minus 3. So now magnitude of series impedance equal to ZC sin hyperbolic gamma L, which is equal to 316.22 from here into sin hyperbolic gamma, which is the propagation constant, is coming out to be J1.58 into 10 to the power minus 3 multiplied by L, which is 400 kilometers. Now this J or I sign can be taken outside, which is equal to J316.22 sin hyperbolic 1.58 into 400 into 10 to the power minus 3. So this quantity value is now coming out to be J186.92 ohms. So 186.92 J is the answer. So the value of the impedance is 186.92 ohms. So magnitude is asked, so you can quote 186.92 ohms. So this is the answer. Thank you.